Okay, so last time we were together, we started talking a little bit about vectors. We need to continue that and then do a little trigonometry. So, Alex,
Can I turn the fan down?
you can turn it off. Yeah, it just gets so hot in here. You can turn it off. So arrows here, so here. Why are we starting? Remember we combing our hair after weight?
No.
Enzo,
Just started, I guess.
Scout, Alex, I got a thing recommended early, so it's not going to go, just go, okay?
What?
I got a thing for you
I don't think so,
for adoration.
One that actually has lead in it? I don't know.
Okay. It's up to you, it's fine.
I may leave just like 5 minutes early so I can get.
All right, so here we go. We are in part 7 through 9. I kind of clumped all that together. And we are going to just do a couple of very, very basic matrix operations. And in fact, I think that you can do this without my help. So the vector B has these coordinates. And I'm very old school. Back when I learned about vectors, we used the kind of less than, greater than symbols, because when I write this, it looks like an ordered pair, doesn't it?
Yeah.
And it's not an ordered pair. An ordered pair is a point, a position. This is a directed line segment. I don't care which you use. Newer notations, yes, but you're welcome to use whatever notation you want. All right, so find 2b. Okay, take a wild guess. What do you think 2b is?
6
6 negative 8. I told you you can figure this out. This means the magnitude, which is the vector word for length. Vectors and matrices have their own vocabulary for some reason. And magnitude is the word that's used for length. Just like this guy right here, which you normally would just think of as a coefficient, it's called a scalar. So that 2 right there is called a scalar. And this indicates we're going to find the magnitude of our vector. Now, that is really, really easy. Remember that a vector tells me how I am moving. So I'm going to pick a random point to start. This does not tell me where I start and end. It just tells me how I get from A to B. So I'm just going to start at the origin. That makes the easiest or most sense. That's the easiest for sure. If I go right 3 and down 4, that would be the vector that I'm talking about right here. Now, there are zillions of vectors with that coordinate, with those coordinates. For example, if I started up here somewhere, could I draw a vector that moved that way? Yeah. I'm just picking the origin as a place to start because that keeps everything easy. Now, your job is to find the length of that vector no matter where it is. Can you think of a way to do that that's really, really easy?
Distance formula.
Well, we could definitely use the distance formula, or we could use the Pythagorean theorem. And remember, the distance formula comes from the Pythagorean theorem, so it's about the same thing. Remember, I went over 3 and down 4, so can I find my magnitude? Absolutely. It's going to be the square root of 25, which is 5. Now, notice that I got my magnitude by doing what? I squared, added them together and took the square root. So the next time you see a vector and you have to find its magnitude, maybe you won't draw it. You certainly can, but maybe you won't need to draw it because this just says I'm going right 1 and up 3. So won't the magnitude just be the square root of 1 squared plus 3 squared? Or the square root of 10? Every time. Every time, that's the case. Okay, now C is a little bit trickier. It says I've got point A, I'm going to B, but I don't know B, but I know that the coordinates of my vector are 5, 3. So I'm starting at 1, 4, I'm ending somewhere, but to get from here to here, I know I go 5, 3. So what do you think that point is right there? 6, 7. And how do we know it's 6, 7? If we're starting at 1 and traveling 5, we're gonna end up at 6. If we're starting at 4 and traveling 3, we're gonna end up at 7. Pretty easy stuff. All right, let's look at D. Now we have 2 random vectors. And we're gonna add them together. You guys in physics, what do we call it when we add vectors together? Starts with an R.
Where's Big Al? I don't remember.
Resultant. It's called the resultant. So when we add vectors together, the sum is called the resultant. So if somebody ever says to you, find the resultant, that means they just want you to add them. Now, any idea? Take a wild guess and you'll be right. What do you think the sum of these is? It's another vector. What do you think?
Negative 7, 2.
Yep. Your geniuses are exactly right. That's all there is to it. Just add them together. How about 2v minus u? Well, what would 2v be? Negative 14, negative 6. And u is 0, 5. So any idea what that's going to be? Negative 14, negative 11. Easy, right? Easy. E, a little vocabulary. We're going to find a unit vector. Anybody have an idea what a unit vector might be? You remember what your unit circle is? What's your unit circle? Centered at the origin with a radius of 1, right? So any vector that is drawn in the unit circle is called a unit vector. So what can you tell me about the magnitude length of a unit vector? It's 1. All right, so let's look at this vector right here, this vector v right here. What is the magnitude of that vector? Magnitude of this vector is not 4. How do we find magnitude again? Look back a couple in your notes. You can draw it. Or you can just remember, if I did draw it, it would be left 7, down 3. So that triangle would be 7 squared plus 3 squared, root 58. So the magnitude of that vector is root 58. It is not a unit vector. I'm going to draw it. Here it is. This is my vector, negative 7, negative 3. It is in a circle whose radius is root 58. Would you agree with that? It is part of a triangle whose sides are negative 7, negative 3, and root 58. Now, I want to take that circle and shrink it.
Could you divide both of them by root 58?
Everything by root 58. That's exactly what you did, Alex. Very good. So we're going to divide everything by root 58. And if I do that, if I divide everything by root 58, now is the length 1. Yep. And what are the two sides? The unit vector for v will be what? Negative 7 over root 58. You don't have to rationalize it. Negative 3 over root 58. vector into a unit vector. All you do is divide his coordinates by the magnitude, and that just shrinks it right down. All right, so now you do it for vector u. You do it for that guy right there. What is his magnitude? What is the magnitude of vector u? 5. So to make that a unit vector, I'm going to do what? Divide these by 5. So what do I get?
0, 1.
Doesn't that make sense to you? When it was 0, 5, wasn't it up here at the top of the circle with a radius of 5? When I shrink it all down, now it's still at the top of the circle, but now the radius is only 1. Okay, perfect. All right, F. I wish we had more time to do all this, but we don't. In vector land, there are 2 ways to multiply. This one is called the dot product. V dot U, the dot product. This one is called the cross product, V cross U. So we can't say times because no one will know which one we're talking about. So we either are doing V dot U or V cross U. The huge difference between these is V dot U is a number. So when I do this in a minute, you're gonna get a number like 6. When you do V cross U, you get another vector. This is really the more interesting one, but we don't really have time to do it. V dot U is a number, V cross U is a vector. All right, so how am I doing this? I am dotting my vectors in D, which are these 2 right here. So -7, -3, dotted is 0 and 5. Very, very easy procedure. Super simple. Take -7 times 0, -3 times 5, and add them up. And that's your dot product. So basically it's x times x, y times y, and add them up. So I told you we were gonna get a number, we are gonna get a number, it's -15.
The cross product is the one with a really complicated formula, right?
Well,
Like with
the
I
formula
hat, J
is
hat, K
complicated, the way you do it isn't so complicated, but the formula is complicated.
Yeah.
It gets more complicated when you write it down, but the procedure isn't that bad. All right, letter G. If we had time, we'll do some. But interestingly enough, you can't cross 2-dimensional vectors. These are 2-dimensional vectors. You can't cross them. So you would need to move to 3 dimensions to do that. All right, G, find the measure of the angle determined by V and U. All right, I'm still using these same vectors. Clearly, if I drew them, they would form an angle. Does that make sense to you? Here's one of them right here, and here's the other one right here, and they form an angle. There are trigonometric ways to do that, but somebody a long time ago used all that trigonometry and came up with a really simple shortcut to find the angle formed by 2 vectors. And here is that formula. V dot U, which we already know is -15. We already did that. V dot U right here, we already did that. Is the magnitude of V times the magnitude of U times the cosine of the angle between them. Now, we know this number, -15. We know that we figured it out a minute ago. The magnitude of that was root 58. Remember that? We squared and squared and add them up. What's the magnitude of u? I erased my vectors right there. 5 times the cosine of theta. See how easy this is gonna be? So we'll divide by 5 root 58. And that's the cosine. And then how will I actually find the angle? What?
Do the inverse.
Inverse, yep, I'm gonna inverse cosine. Since we are in AP pre-calculus, we need to be in radians. So, although in a minute we're going to degrees, but we'll do this in radians. Inverse cosine negative 15. I got 1.976. What about you? So make a little notation. You can find the measure between any two vectors if you know the coordinates of the vector, like we did, -7, -3, 0, 5. If you know the coordinates of the vectors, you can do it in a snap. Find the dot product, x times x, y times y, add them up, and set that equal to magnitude of first times magnitude of second times cosine. Now, quick comment, then I'm moving on, because we got a lot more to do. What would happen if I had two vectors like this? Let's say vector A is -2, 6, and vector B is, let's say 3, 1. What would happen if I had to find the angle between those two? Well, what's the dot product of these two?
0.
X times X, Y times Y, add them up, 0. Now remember, using that formula, 0 equals magnitude of that times magnitude of that times cosine theta, which basically says cosine theta is 0. Right? What kind of angle has a cosine of 0? Pi over 2. Well, wait a minute. If the angle between these two vectors is pi over 2, which is 90, what does it tell me about these two vectors? They make a right angle, they're perpendicular to each other. Actually, in vector land, we don't say perpendicular, we say orthogonal. I told you they have their own language for some reason. But if the dot product is 0, then that means the cosine is 0, which means the angle is 90 degrees. Now, this jives perfectly if you think about it. This vector goes up 6 and left 2. So his slope is -3. What does this one do? He goes up 1 and over 3. Well, wait a second. This one's -3. This one's 1/3. They're opposite reciprocals, which means they are perpendicular, orthogonal. See how it all fits together? If the dot product is 0, your vectors are perpendicular. Okay?
Ayan, so like here.
Exciting. There's a lot to do, let's focus. All right, so that takes care of our little
It's alright.
20-minute
That's on the iPad, buddy.
version of vectors. Now we're moving on to some basic trigonometry. definitely need a calculator
It's gonna be under.
and definitely in degrees. This is set in degrees.
It's a long message, the more you talk
Alright, here we go. Directions says solve the triangle. Do you know what that means?
That's used for high school.
What is solving the triangle? Find everything that's missing, that's exactly right. So we need to find, oh, this will be easy. What's angle C?
41.
I didn't check, is that right?
Yeah.
Alright, so we got that, because the angles of a triangle add up to 180. Now, this is not a SOHCAHTOA situation, because we don't have a right angle, so there's no hypotenuse. This is a law of sines situation, okay? Law of sines. And the way the law of sines works, sine 41 over 10. You guys may have done this in geometry. Does that look familiar to you from geometry? Sine 41 over 10 equals sine 58 over x. When we label our triangles, I can't remember if we've talked about this or not. When we label our triangles, the angles get capital letters, and then the side opposite is the small letter. So this is S, and this is H. And that's C. So we do sine 41 over 10, and then I just randomly said sine 58 over S. Could I have done sine 81 over H? Yes, and I will in a minute. I have to do them both. Okay? So here we go. I'm going to cross multiply and divide. My calculator's set in degrees. I got 12.926 for S. Anybody else get that? Now in right triangle trick, once we have two sides, we can do the Pythagorean theorem, but we can't do that here, not a right triangle. So we're gonna have to set it up again. So we'll say sine 41 over 10 equals sine 81 over H. Law of sines is super simple. Super simple. So sine 41 over 10, sine 81 over H this time. And then we'll need our calculators again. I got 15.055. What is the problem here?
Can't find
Yeah, it's not to the shin again.
We good here? Yeah, we're only doing one law of sines problem, that's it. It's easy. Okay? Now let's look at B and tell me why we have a dilemma.
because we don't know what angle C and S are.
Well, we don't necessarily need to know two angles to do the law of sines, but we do have to have this.
Oh, we don't have it.
You see what's gonna happen? The law of sines is true, but it's not gonna be solvable this time because what are we gonna have? Sine C over 12, and then sine 52 over H, or sine S over 10. You see how you would have two variables in this proportion? And that is not good. When the law of sines fails us, and again, it's true. You could set up a true equation here, you just can't solve it. When the law of sines doesn't work, then we have to move to the law of cosines. Between the two of them, you'll be able to solve any triangle that's solvable, okay? So what does the law of cosines look like? This is one of those deals where I quit teaching the formulas because there's 3 versions of it and they look so hard. It's important that you just know how it works. So here's how it works. It's going to be a big long equation. On this side of the equation is just going to be h squared. On the other end is going to be cosine 52. So I am using this pair right here, my angle pair. On this side is h squared, on that side is cosine 52. And then in the middle is 10 squared plus 12 squared minus 2 times 10 times 12, cosine 52. So on each end, I've got my h's in this case. I got my angle h out here, cosine, and then my side h all by itself over here. And then in the middle is my other two sides, 10 squared plus 12 squared minus 2, that's part of the formula. 2 is there all the time. And then your 10 and your 12. Now we're going to practice again in a second, so just relax with that. Take my word for it. Let's type it in. Honestly, the hardest thing about the law of cosines is remembering to square root your answer. Because you can get all that typed in wonderfully, but then you have to remember to square root it. I got 9.810. Finish this problem, then we'll do another one. I want to finish this one because our job was to solve. So now what do we need to find? Maybe angle S. Look what you have now. What can we do now? Now that we have that pair, what can we do? Well, sine. Now we can do all signs. So sine 52 over h. Now remember, that's in our calculator, so we're not going to round it off and type it back in. We're going to go ahead and just pick it up right off the calculator. But sine 52 over h is going to equal sine s over 10. So sine s will equal 10 sine 52 over h. Remember, that's in my calculator. Now, caution. What's going to happen when you type this in? You're going to get a decimal. Is that decimal your answer? No. What do we need to do? Inverse it. Yeah, we need to inverse it. So, second sine, 10 sine 52 divided by my last answer, which is that 9.810 number. I got 53.44. 53.442. Everybody get that? Make sure when you're typing these in, as soon as you press sign, your calculator will throw in a parentheses. Make sure you're always closing it after the angle. Did you get 53.44?
What'd you just multiply it?
Inverse sine that fraction. Alrighty. Now, what about angle C? Okay, what about angle C? Won't we just subtract from 180? 74.558. You could log signs again, but they have to add up to 180, so what does it do? And I know I'm throwing a lot at you, none of it's hard. It's a lot. Let's look at another law based on this problem. How do I know that this is going to be a law cosines problem? Remember, you have two options, law sines or law of cosines. How do I know this is cosines? Because I don't have this. Remember, if you're going to do sines, you have to have that pair so that you can set up your proportion. I don't have it. So I'm gonna jump in and do the law of cosines. Okay? Now, doesn't matter where I start, I'm gonna find the biggest angle. I'm gonna find the biggest angle of this triangle. Which one will be the biggest? H. So I'm gonna find H, angle H. Now in my law of cosines, which only uses one angle, and I've decided it's gonna be H, out here on this end, I'm going to have cosine H. That's my variable this time. Which means, what's gonna be over here all by itself? 14 squared. If I had decided to find the smallest angle, then this would be cosine S, and this would be 10 squared. All right, so we got both ends of the problem done. Now, everything in the middle is gonna be the 10 and the 12. So it's going to be 10 squared plus 12 squared minus 2 times 10 times 12 times cosine H. Be careful when you type this one in. You can't type all of this because this part of it is hooked to the cosine. So don't type all that in at one time. Let's see if you can figure this out. You gotta find the angle H. Let's see. Gosh, did you get cosine H equal to 0.2? Okay, so then what? Yep, second cosine that answer. And it looks like angle H is 78.463. All right, where do we go from there? Now you can do the law of sines. So go ahead, you and your partner, let's finish the problem. Now remember, when you do the law of sines, don't use that rounded off number, use the number that's in your calculator. We don't want to round anything until the very end. see first. I don't know what you did, that you should be hopefully with me there. A little bit more with triangles to go. Everybody okay with that? Alright, I'm gonna hold on D, for a second. Just gonna hold off on that and look at number 11, do the area first. And then give it time to come back and do that other one. What do you think of when I say find the area of a triangle? Of course you think 1/2 base times height, that's what all good math all good math students think. 1/2 base times height, and that works, always, 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 always. The problem is, usually, we don't know the height. Usually, we know sides and angles. Now, could we find the height? Absolutely. But there are a couple of shortcuts that make finding the area of triangles super easy, okay? The first one I want to derive for you because I want you to see how awesome it is. Triangle XYZ. So let's say we want to find the area of this triangle. I'll drop a perpendicular. We'll call it the height. I know that the area of this triangle is 1/2 the base times the height. Agreed? Like this little triangle right here is a right triangle. So isn't it true that the sine of x equals h over z, opposite over hypotenuse? I'm just looking at this little triangle right here. So h is z sine x. So the area of my triangle is 1/2 y times z sine x. And that, guys, is awesome. Because what does that say? That says the area of any triangle is 1/2 two sides times the sine of the angle between them. So what is the area of this triangle? Without doing any work, the area of this triangle is 1/2 10 times 12 times sine 37. The area of a triangle can always be found by taking 1/2 side times sine of the angle between. Now that can be a complication. It has to be the angle between. So 1/2 side times sine. Type that in on your calculator, and that's the area of this triangle. 36.109. Now you have to admit, that is awesome. That is so easy. 1/2 side, sine. Now let's look at the next one. We're finding the area of this triangle. Looks very familiar, doesn't it? And that's just because my brain was on autopilot or something. We're gonna find the area of this triangle. Now let's pretend, yeah, he's looking back. Let's pretend we've never seen this before. We have, but let's pretend we haven't. To find the area of this triangle, what do I need? an angle, right? So let's find an angle. We know how to do that. Which angle do you want to find? C? Now, how will we find C? Can we use the law of sines? Nope, gonna have to use the law of cosines. So if C is my angle, then over here will be 12 squared. And then what will be in the middle? Can you remember? 14 squared plus 10 squared minus 2, always 2, times 14 times 10. Now we're going to carefully type this in. I can't remember
Need points for what?
when I erased it. I got 57.122 for my angle C.
Yeah, that's right.
That's what I had before. Now can I find the area? So the area will be 1/2 10 times 14 times sine. Remember, area is 1/2 side sine. So 1/2 side sine of that angle, which is in my calculator. I don't want to round it off. So 1/2 times 10 times 14 times sine answer. Did you get 58.788 basically? Everybody get that? Now, good thing you're all sitting down, because I'm gonna knock your socks off. I want you to type this into your calculator. Give me a minute here. Type that in. So multiply those numbers together and take the square root. What'd you get? Didn't you get exactly what we got last time? So cool! This is called Hero's Formula. Actually, it's Heron of Alexandria. And Hero's Formula, he's so smart. These guys are figuring this stuff out without calculators. I mean, they're doing it like on the beach in the sand. I mean, these guys are brilliant. And a long time ago, he figured out that you could find the area of a triangle by finding the semi-perimeter. So the perimeter of this triangle is 36. Half of that semi-perimeter is 18. So that's where that number came from. It's half the perimeter. When you find the area of a triangle, it always involves a half. 1/2 base times height, 1/2 side sine, semi-perimeter. There's the half right there, okay? Then take that number, that semi-perimeter, minus each side of your triangle. So I took 18 minus 14, 18 minus 10, 18 minus 12. That's where these numbers came from. And you just multiply them again and take square root, which is a whole lot easier than finding the angle. Now we can do it this way, we did it. But Hero's Formula is a really handy thing to have in your back pocket.
How did he figure that out?
I don't know.
It's so unintuitive.
Why were they worried about that? Like, they were like,
They're just smart people that enjoy thinking.
no, but
You know how
like
you
they were worried
doodle
about
and draw?
surviving. Like,
You know how you doodle and draw?
yeah, I guess.
They do this. It's amazing, amazing. His name was Heron of Alexandria, if you wanna look it up. All right, we have one more area problem to look at. So you and your partner right now, oh, by the way,
This is in the Library of Alexandria.
Hero's formula is not recommended unless you know all three sides. Any round-off error that you do is going to get multiplied several times. So let's say we didn't have all this, and we found this side and rounded it off on our calculator, okay? And then we were using Hero's formula. Do you see the problem with that? It gets rounded off when you compute the perimeter, and then it gets rounded off in each one of these. So, unless you're gonna carry all that on your calculator, which is fine, don't use Hero's formula unless you know all three sides. All right, so with that in mind, try C. You and your partner try C. You're finding the area of this triangle. Let me know if you disagree. I'm trying to figure out where we sit today. Anybody know?
Oh, all juniors are on the floor.
What?
All juniors are on the floor in the chairs.
Too bad.
What's the word number again? Oh, you're
So I beg for chairs. I never get a chair. I just have to sit in the bleachers. So you know that for a fact?
Yeah.
Alright,
I set it
how
up.
does that work? Oh, you use different base?
So what I did was I found angle S and then added those and subtracted from 180 to get H. I don't know if I still have it. So H was like 95 point something degrees. Then 1/2 side, side, side. Right? So did someone else besides me get 59.729?
Yeah.
All right, we need to look quickly at the one that I skipped. This problem is problematic. Does anybody see an issue with that problem? You really gotta think back to geometry. This one didn't have, or actually that one has the same issue. The one we looked at a minute ago, where we had all the sides, that wasn't a problem. The one we did before that, that looked like this wasn't a problem. This one wasn't a problem. The reason those weren't problems, think back to geometry, this is side, side, side. And in geometry, we know that side, side, side is a congruence postulate. This one is side, angle, side. This one was angle, side, angle. What's that?
It's a bad word you can't
Bad
use.
word you can't use, that's right, I learned that the hard way. I was teaching geometry. My kids kept messing this up in their proofs, and so I had in great big letters, I said, you guys, this is a bad word, don't use this in your proof. So I had ASS written in like gigantic letters, and guess who came in at that moment? Sister Thomas Moore, who was our vice principal, to observe me. And the first thing she said is, Mrs. Ford, why do you have profanity on the blackboard? So I never use it. SSA now, SSA. Can't do it, it's not a congruence postulate. All right, it's not a congruence postulate. Now, does that mean the triangle doesn't exist? Sometimes, but sometimes it does exist in multiple forms. So I am gonna stop there, and tomorrow we have or next time I see, we have two things to do. We have to talk about that, and we have to do a quick survey of matrices, then we have to review, then we have to take a little quiz. But we have 90 minutes, so we can get it all done. So, you should have your homework.
Filling that all in the day.
You should be doing your homework up through 11 now. You should have up through 11, be working on that.
Wait,
I'm gonna-
done right now.